Okay, when I left off in the last installment, one of the things I wanted to do was see if I get this CRT seated any better. In particular, there's a gap up here where this rubber support's supposed to fit in tight around the neck of the CRT. So what I think I can do is raise up the neck of it and then push the whole CRT back. So what I've done is I've loosened up everything. So this band here is loose, and I loosened up these wing nuts here. And it turns out that I know you could slide this stuff back and forth. They got these slots here, but you can also move this stuff up and down. So now that this is loose and this is loose, I can actually move the whole neck up and down. So if I move this up a bit, you have to be careful when you do this, you don't want to crack the neck off. Alright, so get that up a bit, I'm going to push the CRT back. And there we go. That is much better. Now, the downside to doing that is not a whole lot of meat left on the front down here, because now it's actually back behind this metal band a little bit, and this needs to be straightened out. So probably get away with that, but the band should really be back about ½ inch that way. So there's one other thing I can do. It's going to be a little tricky. I'm not entirely sure how to get at them, but there are two bolts, two on either side. If you loosen those up, this entire top assembly can move back and forth. Problem is, this stuff's in the way. I might be able to get an extension socket down in there. Let's see, it's probably 1/4 inch nuts. That. And okay, I think I'll just be able to do it. Probably help a bit too if I slide the yoke back more. Alright. Loosen up. This makes me wonder, because there was a 17 BP4 in here, which is exactly what I'm replacing with. So, what I took out was a rebuild, and when they rebuilt it, the dimensions might have changed slightly, and I'm sure from manufacturer to manufacturer there was some slight variation. You look at the dimensions on CRT data, they give it like plus minus ½ inch, 1/4 inch, whatever. But also, this thing might have originally had a 16-inch picture tube in it, and when they, or it was originally designed for a 16-inch, and who knows if it was ever properly tweaked to hold it. Alright, so you get the idea. I'll loosen up one more, and I'm going to slide this whole thing back, slide the picture tube back, and get everything snugged back down. I'm just glad they give you this much leeway with all these adjustments so you can accommodate variations in the picture tube. Alright, I'm going to attempt to adjust the horizontal drive now. So I've got my test point hooked up to a VTVM. It shows about 23 volts, but I know this meter's off a little bit, so it's actually closer to negative 27 volts. So the idea is you're supposed to adjust that control until the pattern starts squeezing in at the center of the picture. Then you're supposed to read the voltage off the meter and back it off 2 volts from where the squeezing started. And the final reading should be between -20 and -28 volts. So I'm actually kind of right there about now, but I want to try this adjustment procedure anyways. Now, as confusing as that may sound, the real problem with doing this is the horizontal drive adjustment is way down there in between the picture tube support and the high voltage cage. And you got this nice lead here running about 16,000 volts. So I've got to get one of my plastic alignment tools down in there and adjust it. And I don't think they're all that long. can't do this with the horizontal disabled because that's what you're adjusting, so yeah, my tool isn't going to quite make it, so I don't know how I'm going to get this down in there to adjust it while avoiding shocking myself at the same time. So I may have to tape a couple tools together or do something. I guess one could also take this cage off, but that seems like a lot of work. Plus it's got this support here for the high voltage lead. Not the best setup. Every other set I've worked with the drive control has been out the back of the chassis. I just couldn't find any way to get at that control from the top side. Then it dawned on me that maybe you can get at it from the bottom, and yes, indeed you can. It's this trimmer cap right here, so I'm not sure why they label it on top and point that out in the instructions. And I'm not saying you can't do it from the top, but boy, it's a whole lot easier to get in from below with just a plain old screwdriver here and adjust this trimmer cap. And it does indeed make a big difference. So right now I've got a bias of around minus 15 volts. I'll leave the light on. That should be alright. And now I'm going to adjust that cap. And as you can see, as I adjust it, I'm turning it down now, so I'm going more and more positive with the bias. Now the screen's just blanked out. I'm not going to go the other way. Minus 15, minus 20, and see that picture's getting way brighter and crisper. And get to a certain point where it just doesn't change any. Now what I'm not seeing is what they were talking about, where they say where it starts bunching up in the middle of the screen. Oh, unless that's what they mean. Okay, that's probably what they're talking about. Yeah, okay. So you can see that there's stripes in the center of the screen there. The camera's picking that up. And it's right around there they kind of disappear. I said to back off a couple volts from that point, so that'd be around there, which, not surprisingly, is about where it was before I started. So I kind of thought the picture looked pretty good the way when I started, but it doesn't hurt to double check these things. Now, as far as the alignment goes, forget it. I'm not doing it. This set's playing well enough as it is, because it is a pain. I printed out part of the instructions here, but the real reason it's a pain is on another page. I'll show you on my computer screen. So here are those alignment instructions again. Sound isn't too bad to do. Inject a signal in series with a 0.01 microfarad capacitor, inject to this point, connect the VTVM up to this point through a 47K resistor, and tweak the coils and check for a certain reading. Not anything too complicated. Here, ignore how you inject the signal, and inject it with these various frequencies. Again, 47K resistor in series with the probe, and you peak these various coils, and use a 4.5 volt battery on the AGC for fixed bias. Alright, that's not too weird, but this is how you inject the signal. Connect signal generator to adapter and connect adapter to pin number 1 on modified tube, see figure 7. So, if any of you watched that Dumont series, I had a modified tube in that one where I had to clip a pin short and then tack on a lead and inject the signal. This is a similar setup, but it's actually more complicated than that. You need to make this. So you inject your signal on pin 1 of a modified tube, but you also have to build this whole network here and this cable, including a 1.5 volt battery to give a bias to the whole thing. So here's a schematic on that. I'm not going to do all that. The set seems to be playing pretty good. Bandwidth is all right. The sound is pretty good, and I'm glad because I don't want to do all this work. I just wanted to swap out the picture tube and check the tubes and tweak things a little bit. But just to give you some idea, I was saying how complex that Dumont alignment was. Well, other sets are just as bad or worse in terms of having to modify tubes, making custom probes, or signal injection modules. So there you go. I'm doing a final check before I put this back in the cabinet. And I've noticed a few things. One is that those retrace lines are kind of annoying, so I think I'm going to have to go back and see about adjusting those resistor and capacitor values. So to make them go away entirely, I do have to make the picture pretty dim. Something else that there's nothing I can do about is that there are actually some flaws in this picture tube. I was cleaning the glass. I just assumed that was dirt at first, but no. That's dirt. I can get that junk off. But here, there's a minor bubble in the glass, not that visible. There's also one right there. And that is just like a hunk of crap inside the glass. I don't think it's in the phosphor layer, and it's certainly not on the surface. It's like in the glass. I guess that was acceptable back then. Alright, I'll have to check that out tomorrow. So I'll just have to live with that. I've seen bubbles in the glass before, but that's about as bad as I've ever seen in terms of just like some junk in the actual glass. As far as the sound quality goes,
school ends, but free lunches for your kids don't have to. Find your local.
It's a little bit of a buzz.
Parents sure have their hands full, and they could use an extra hand. Now,
But it's not that
state
bad.
offers free or low-cost health
I
insurance.
think I'll try doing is figure out where the ratio detector is. It's probably the top of this can right here. And just do a minor tweak left and right and do it by ear and see if I can reduce that hum or buzz any.
This proves Khan's still on the island.
I've temporarily reconnected that retrace suppression circuit. I want to take a look at it with the scope, see if it can be improved any. So that's this resistor and capacitor in series. And here's where it connects up to the CRT. Let's see what kind of signal we've got there. Okay, so there's the retrace suppression pulse, but then we've got this ramp, and that's got to be what's accounting for the brightness gradient. That should come straight right back down here. I suspect what's causing that is not this, it's this cap over here. So there's a wire that runs from there over around to here, and that's where those wires go to the CRT, and there's a cap going to ground. So when we get that pulse, it's charging up that capacitor, which is then slowly discharging. So I can think of a few possibilities. One, take that cap out. It's there to filter out any noise from getting into the control grid on the CRT, because you don't want any noise getting into your picture. Or I could put a capacitor in parallel with that to bleed off that charge more quickly. Or I could try reducing the size of that capacitor. Now, somebody else in the video camera just happens to have restored a very similar Sentinel set with a 19-inch CRT, and I think he said he used a 0.01 microfarad cap. So the effect of that, I imagine, would be that it'll be imparting less energy during this pulse, so this pulse will probably be shorter, and correspondingly this ramp will be lower. Still have to find a way to completely eliminate it though, so let's do some experimenting. Here's a quick sketch of the circuit we're looking at. I was wrong, it actually drives the cathode, not the grids on the CRT. So there's a brightness control, varies between ground and some positive voltage, feeds in through 220K over to the cathode. So that's the operating point. And here's that filter cap going to ground. And here's the resistor and capacitor in series picking up a pulse from the vertical output transformer. So what I've done now is temporarily disconnected that cap.
My comb could never kick like that.
And well, there's the effect. So what I think we're seeing here is noise from the video signal being superimposed on it. And it still has a ramp. So that really didn't take care of the problem. Really annoying sound in the audio too. I don't know if that's my modification or the actual content. But, you know, watching it, you don't really notice the effect. And I think that ramp is actually a bit less. But definitely still an issue, so I can blank out the top and there's still an image at the bottom. So, alright, so much for that idea. So, next I will try using a much smaller cap there. I'm going to go with a 0.01 and see how that works out. Okay, that's looking a lot better now.
If who manages to extract the element X, there'll be no object in keeping us alive.
And here, it looks similar, but the voltage scale before was 10 volts per division. Now it's down to 5.
You are to come.
Hello there.
Also notice that this signal definitely varies with the picture content.
Won't you sit down?
Now that we've got a better background here, you can see it's pretty uniform brightness
Would you like a
from
drink?
top to bottom.
Yeah, why not? You know, I'm slightly confused.
So I think
You
that's
take your typical
it. It's good enough for me.
Hurry. No.
What are you saying?
And by the way, when I tried adjusting that
If you'll excuse the corny cliche.
coil, that really had no effect. I made a slight tweak, but I really
My answer.
think that's as good as the sound's going to get, which is
Did
pretty
you ever
darn good
hear it?
anyways.
Don't judge a book according to its cover.
Or a snake.
There's a slight buzz, but it's really pretty minimal. Alright, so I'm going to do one last check of the linearity, and then put this back in the cabinet. Well, I got the chassis back in the cabinet, but I'm not entirely happy with how it's sitting in here. There's a bit of a gap at the top, and it's kind of tight at the bottom, so the picture tube is actually kind of tilting back a little bit in that yoke. So I hate to do it because this thing is heavy, but I'm going to pull it out one more time and check that CRT orientation and see if I can kind of tip it up a bit better and then try to seat it in there. Also, when I got this, there's a rubber bit of molding around the inside, and it was kind of crushed in this corner. Tried to straighten it out as best I could, but it's really kind of hardened and kind of crunchy, so for now I'll just live with it. So what's inside there is a plastic, I think it's plastic, it might be metal, bezel that goes around here, and then there's rubber around the inside perimeter, and it's supposed to fit snugly against the CRT. Not the end of the world if that's the best I can get it, but I'd like to try a little bit better. Also, there's less of a gap on this side than that side, so it might be a little bit cocked in there too. And the knobs are centered. Actually, they're over that way a little bit too much. The set should actually be over this way more, which would make the gap on this side even more noticeable. once I do get it back up on the workbench, something else I want to take a look at is there are still visible vertical lines on the left-hand side. Adjusting the drive did not eliminate them. I suspect that is a little bit of ringing in the horizontal yoke signal. So, check on that. And unfortunately, that flaw in the picture tube, now that I know it's there, it is a lot more visible than I'd like. But for now, I'm just going to have to live with it. So, I thought I'd wrap up this project in this video, but there's going to be at least one more installment.
Kong! Stop that ship! Get the ship, Kong!
Sir, hello. Will he catch it?